Let's integrate x cubed times ln of x squared plus 1. For this, we're going to use integration by parts because we have two functions multiplying each other, and u substitution will not work. So for u, you want to use the acronym LIATE, and L stands for log, so that's going to be the natural log of x squared plus 1. dv is everything else. The derivative natural log of x squared plus 1 is 2x over x squared plus 1 dx. And then the antiderivative of x cubed is x to the fourth over 4. So we're going to multiply u times v minus integral v du. And so when I multiply 2 with the fourth, I get a half. Pull that out. X to the fourth, x to the fifth over x squared plus 1. Now at this step we can use long division, but that's going to take a while, or we can make a substitution. And the substitution we're going to make is x squared plus 1. So then du is 2x dx. So the way we're going to think about this is we have x to the fourth times x dx over x squared plus 1. Now, x squared plus 1 is going to get replaced with u. X dx, that is du over 2. And then x to the fourth, well, I know that x squared is u minus 1. So x to the fourth is u minus 1 squared. So then we're going to have the negative 1/2 still. And then we have u minus 1 squared du. And actually, we're going to multiply the 1/2 outside by the other 1/2. And so this will be negative 1/4 u squared minus 2u plus 1 over u. And then I can split this up into three separate fractions. So this is u minus 2 plus 1 over u. And then this is u squared over 2 minus 2u plus natural log of u plus z. And then don't forget, with all of this, we still need to include this term. So, okay, but before we do that, let's keep multiplying this out. So this is negative u squared over 8 plus 1/2 u minus 1/4 natural log u. And then we said u was x squared plus 1, so I'm going to replace that. And because x squared plus 1 is always positive, we're not going to use absolute value for that. And let's not forget the square here. And then when we bring this one down, that's going to give us x to the fourth natural log of x squared plus 1 over 4 minus, and then we have x squared plus 1 squared over 8 plus 1/2 x squared plus 1 minus 1/4 natural log of x squared plus 1 plus c. If you want, this is good enough, but what you can also do is factor out the natural log, distribute the squares, and the alternative form is 2x to the fourth minus 2 times natural log x squared plus 1 minus x to the fourth plus 2x squared over 8 plus c. But this is a lot more work and it's not worth it. I think this is good enough on the top.